this is the first lesson, and I think it's beneficial that we start with a bit of a history about Databricks itself. Uh, when Databricks was founded, who created Databricks, how actually Databricks was, started in the first place. Actually, to start this story, I think it's gonna go back many years behind. I'm gonna use a whiteboard. I hope you see my screen clearly. So it started when businesses actually started to accumulate vast amount of data in databases, right? This databases comes usually from their customers. So their customers bought an order or place an order or like create a delivery or something like that. It's something created in the database. And then inside the business, there is a group of people, usually call it the data analysts or business analysts, whatever they call it. This will start to ask certain kind of questions like how many orders did we sell last week? What kind of offers should we give to our customer? What is the discount we should place on certain products, right? This kind of question usually business ask, but they quickly realize that they cannot ask this question on this kind of database. By the way, this is a database like the likes of MySQL, the Oracle, all these databases. We call it operational data stores or operational data stores. We call it ODS for short, or OLTP, Online Analytical Transaction Processing System. So you realize that these systems are not designed for analytics, they are designed for operational. The solution didn't wait for long. The solution was easy. You're going to create another bigger database, and they call it the data warehousing. Where now the business analyst, they don't have to ask this question in the ODS database, they will ask it in the data warehouse itself, right? So they ask the question to the data warehouse, and this was like great. They worked great and answer majority of the business questions. We talk about data warehouse is almost like a 30 years old technology, right? The data inside data warehouses is coming from operational databases. So we're talking about tables and relations and columns and rows and things like that. We call this kind of data structured data because data is really structured in a way that you can easy for you to analyze. But what happened is that as technology mature, we started to see different kind of data. It's not really structured data or tables and columns. We started to see videos, right? We started to see audios. We started to see JSON files, right? Or maybe XML files, or different kind of files, CSV, you know, uh, all this kind of data. This is not tables or relational data. This is just amount of data that the business need to analyze. Usually coming from source systems, the likes like if it's like, do you have a system like an HTTP system that gives you logs? You wanted to analyze for threat detection. You're gonna see like a log file, completely unstructured. So you need to figure out a way how to read and analyze this file. But the business at then they didn't have the technology to do this. So all they did, they just dumped all this data into a place in their storage. Eventually, this place we call it the data lake, right? We call it data lake, just a place where you dump all the data that you cannot analyze with the data warehouse, just keep it there. But also they didn't wait for long. There is a technology that was created in 2004 by Google. It's called MapReduce, which is in another way, it's a way where you can analyze the big amount of data by spreading it into many machines in your network, and then spread the task of analyzing data to these machines, and then reduce the job or read data and present a result to the user. And the first system that actually implement this kind of technology is called Hadoop. Hadoop was the a system that you can use to analyze big data, and this is really, you can consider this the birth of the big data analytics, where you started to see data not on the gigabyte scale, but data on the terabytes and petabytes of scale. And you use Hadoop, which is powered by MapReduce technology. Most of the time, Hadoop job was really to read the data and make it structured so you can fit it back to the data warehouse. Until Hadoop became mature and it started to have its own ecosystems of tools that you started to see data warehousing inside Hadoop itself, right? In a way or another, like things like Impala and this kind of system that can you fairly good data warehousing based on the Hadoop. But the problem with Hadoop is if you want to use Hadoop to do something else different than data engineering. For example, if you wanted to do machine learning is an application that does a lot of iterations over the data. It goes back and forth. to tune the parameters, to do back propagation. This kind of machine learning stuff, it's fairly the core part of machine learning is you do several iteration on your training data to optimize the hyperparameter of the machine learning model. Now, if you try to do this in Hadoop, you're gonna quickly realize the problem with Hadoop, which is Hadoop is based on map reduce. That means there is a lot of disk I/O involved when it does these iterations. I/O every now and then, whenever you try to do an iteration, there is an I/O or a disk read or a disk write. So this is not really ideal. Makes the ML project really slow. So the solution to this problem was by another system called Spark, which is kind of does what Hadoop does, but all in memory, right? It's like a Spark, like that's why it's called like maybe Spark for that name, because it's really like very very fast. So it's all based in memory. And the people who created the Spark are actually the founders of Databricks. So this is the founder of Databricks. They created Apache Spark and they released it to open source. It's actually called Apache Spark because it's a fully open source project that is now supported by the open source technology. So what Spark does? Spark was like a much, almost 100% faster than Hadoop in some scenarios. It's all in memory. It works as a like very fast on machine learning application. In fact, the first time they used Apache Spark was in a Netflix competition. Like it did very very well on this competition. But Spark birth was really advanced the machine learning and data and AI using the big data analytics. And like I said, the founders of Apache Spark are the people who created Apache Spark are the founders of Databricks. So Databricks founded in 2013 as the company behind Apache Spark. Initially started with Apache Spark, but then they added a portfolio of different products. Pretty much all of them are open source. Things like MLflow for managing machine learning models, Delta Lake for managing your data platform as a whole, and many, many other open source projects that makes it easy for you to use data analytics. So, in fact, if you look at the Google Trends, for example, you see Hadoop here in the blue, Apache Spark on the red. Hadoop really had like a time where it was like the big data analytics platform. I think it peaked in 2015, 2014, but then ever since Apache Spark has taken off, almost now exceeding Hadoop. Hadoop is like slowing down now, but Apache Spark is taking off, and it's now pretty much the standard tool for analyzing big data and AI. In fact, if you wanted to know, and also because Apache Spark is the core product for Databricks, and Databricks as a platform is created using technology called the Lakehouse. So Databricks is primarily now building a lakehouse, which is really a combination of both. So if you look here, this is not where the story ends, because if you look at the screen now, you see organization now have to manage two systems. Data Lake has evolved using Apache Spark, but we still have the data warehouse. Do organization really still have to manage two systems to analyze this data? One is Apache Spark based, which you call it the data lake. One is data warehousing. Actually, and this is the vision of Databricks. Databricks created a new technology called the Lake House. So what is a Lake House? Is mainly combining the power of Apache Spark and Data Lake with the power of data warehousing. So we've got this all merged together into this technology from Databricks, and the technology is mainly building a data application that has you can do machine learning, AI, data warehousing, and all this kind of data application in one place, which is the Lake House. So what is a Lake House? If someone asks you, Lake House is a technology that combines the power of data warehousing with the power of data lakes into one place, where you can have centered governance. It's an open source. It's actually also multi-cloud. So if you wanted to use it in a different cloud. One thing to note is Databricks from day one was a cloud-based data platform. Databricks does not run on-prem, it's all on the cloud. And this is maybe the difference between other offering in the market, because Databricks is strictly a cloud. And not just one cloud, Databricks runs on AWS, on GCP, and on Azure. So you can use Databricks pretty much on most of the big clouds, and Databricks offers a lakehouse solution. So the lakehouse technology, if you also wanted to take a look at who actually looking this is, if you search for the Gartner hype cycle for the lakehouse, you will see that the lakehouse is actually one of the technologies that are on the rise among the other data and AI projects. It's almost at the peak of the data of its life cycle, because lots of technologies now are based on lakehouse. If you go to the Google and search lakehouse, you'll see many companies now offering a lakehouse solution, like Google, like Azure, like Databricks, Microsoft, AWS, all of them offering a lakehouse solution. But Databricks was the first company to create the whole lakehouse thing. So this is like a good historical lesson about what is Databricks, when it was founded, and it's gonna be we're gonna rely like build on top of this knowledge on the coming lesson. So thank you very much, and I see you in the next lesson.